Hi, welcome back to Math 112. In this video, I'm going to introduce the notion of sinusoidal graphs. So this will be the first topic covered in section 6.1. Now, what we're going to do is stretch out our unit circle. So I'm going to open up a Desmos graph here. And what I have here is our good old friend, the unit circle, and I've labeled all of the points and the sine and the cosine of all of those points. Now, what I'm going to do, so you'll notice my x-axis. Let me So notice that my x-axis is labeled oddly. It's labeled in multiples of pi. And actually it's labeled in multiples of pi over 6. And we tend to do this. We usually label pi over 6, pi over 4, and pi over 3, and 0, 1, and we keep on going. And that's because we tend to do this work in radians. We can do it in degrees, but we tend to do it in radians. So I'm in radians here. So this is the radian version of the unit circle. And this, so I've got a couple of things on here that will show up better in a minute, but I've got a line coming out to here to this point. And what I'm going to do is I'm going to move around my unit circle. But as I do that, I am then going to plot along the x-axis this angle theta and the cosine of that angle. So my y-axis is going to represent the cosine of my angle, and my x-axis is theta. So, like when I get to pi over 6, I'm going to plot the point pi over 6 cosine. Let's do pi over 3. When I get to pi over 3, I'm going to plot the point pi over 3 1/2. Okay? And because if my angle is pi over 3, the cosine of pi over 3 is 1/2. So let's take a look at what happens here. I'm going to shrink down my unit circle a little bit, and I'm going to take off those outer labels just to make life a little simpler. Okay, all right. So I'm going to move along my unit circle. Now before I do that, let's just put some values in this table here. Let's put pi over 6, and then Desmos is going to calculate and for me the cosine of pi over 6. And notice Desmos is also plotting out those points as we go. So Desmos is, remember what my x's are. My x-axis, I can label this theta. It's not pretty. I wonder if I can make it pretty. Let's try that. No, wait. No, I can't. All right, so this is just going to be, see, here we go. My angle. And this is going to be my cosine. Okay. So that's what Desmos is plotting here, is pi over 3 is the x-axis, and then the cosine of pi over 3 is the y-axis. And I'm just going to go ahead and build some of these out. Whoops, that's wrong. Okay, now what I'm going to do, so if I move my angle out to pi over 6, you can see I'm building that curve. So that red curve that is being built here is the cosine function. That curve has equation y equals cosine x. Right there. Okay? And in order to talk about what we want to talk about, I need you to notice that it's starting to repeat. And in fact, if I want to make those go away. So this guy kind of does the same thing, but he keeps going. So I'm just going to let this angle up here play around. And notice that we are again building that cosine curve. Okay. Now, I've gotten to about 2 pi, and watch what's happening. So the value at 0 and 2 pi is the same because we are going around the circle a second time. And this is one of the things I want you to notice, is that cosine repeats, right? And we're going to talk some more about this. And we could do this same development with sine. I'm not going to, but I am going to show you the curves for both sine and cosine. And then in the next video, I'm going to talk about the properties of both cosine and sine. So let's do this. So I'm going to put here on this graph the function y equals cosine x. And I'm also going to change my scale, my step size for cosine, or for the x-axis. That gets me my pi's, which are handy because I want to point out some things to you about cosine. So remember, cosine is related to the x-coordinates of the points on a circle at specific angles of rotation. I'm going to scribble on this, so let me pull it in here, crop it down, make it a little bigger. And I want you to remember this is the function cosine x. A couple of things to notice. The cosine function goes through the point 0, 1 and hits 0 at your pi over 2, 3 pi over 2, negative 3, all the way, and we go on doing this forever. Notice also that cosine alternates. The y values never go below negative 1 and never go above 1. Think about why that might be in terms of how we generated this function based on that circle. It's going to come back. Okay, so that's cosine. Let's take a look at sine. And sine, you'll remember, is related to cosine. And so it shouldn't surprise you that the curve looks a little bit different. It looks very, very similar. It's just shifted. All right, it's shifted sideways. And in fact, it shifted sideways by pi over 2. So in other words, if I pick up my cosine curve and I scoot it left or right pi over 2 units, well, I'll scoot it left pi over 2 units, I'm going to get a sine curve. So this one is y equals sine x. And notice that the sine curve goes through the point 0, 0, and it hits 0 at multiples, integer multiples of pi. But like cosine, sine is bounded on the bottom by -1, and on the top by y equals 1. All right, we're going to talk some more about these two functions and their properties in the next video.